Okay. That's new. All right. Hi, everyone. It's been a while. Apart from, the decimation of our daily schedules that basically everyone's been enduring for about half a year at this point. Everyone in this country, at least. It's been pretty tricky to navigate my new job, learning a completely new set of skills and making sure my wife has enough time to herself to do her own work and, just stay sane. I also anticipated that, starting a new job with a bunch of people whom I've never met was going to, be a little bit different during this period. But what I didn't truly anticipate was how tough it was going to be to not be able to convey those like subtle social cues that are unspoken but, absolutely critical and mostly subconscious, right? And what I mean by that is like I've mentored quite a few, high school and college students who are interested in going into biomedical science. And, I've always stressed, like I'm sure basically everyone does, that first impressions are incredibly important, right? That the perceptions people form of you during the first few minutes and hours and days are sort of like out of their conscious control. And, things like how you're dressed, your posture, the tone of your voice, all those things matter when people are forming those initial impressions, right? Not exactly earth-shattering insights, of course, but, it's easy to forget about those things when you're in an entirely new environment, learning what's basically an entirely new professional language. And then, of course, after those impressions are formed, you have to actually perform, and be impressive and all that, obviously, but, those initial impressions are super important. And so, I started this new job that's really quite new for me, at least for someone in my discipline. People don't really know what a neuroscientist is, and it's not like that's particularly unusual, right? But normally they'd be able to see me sort of subtly smile at a joke they'd made or reference they made to something, and, it wouldn't make sense to just like guffaw and like crack up. I'd come across as like a total weirdo. But of course, we're all wearing masks. And it's, pretty much either eyebrows or vocalizations. That's what you got. The whole lower half of your face is covered, right? Just like totally not something for which I'd prepared. So I think I'm adapting okay, but we're doing such an awful job at confronting this pandemic in the United States. It's sort of become our new reality. So anyways, since I have a daughter that's a bit over a year and a half old, I've contemplated what effects COVID-19 is going to have on the social development of babies growing up without access, to normal childcare environments and social interactions that they afford. And I've sort of realized that my baby isn't the only one navigating this strange landscape. So my guess is that there will be PhDs that are minted on studying the social differences of children, particularly young children who've grown up, bereft of the social interactions that most babies have. All right. So something very neuroscience-y kind of broke into popular culture a bit over a week ago, which is kind of strange because it feels like it was like a month ago. The passage of time is like meaningless to me at this point. But anyways, so Elon Musk hosted a demonstration of the progress that one of his companies that's devoted to creating a whole brain computer interface called Neuralink has made over the past year. And so, if you're interested in a deeper dive into like a scrutiny of the science of Neuralink and, the whole endeavor to create a whole brain-computer interface beyond just like Neuralink, I have a podcast called Wired to be Weird where we spent, quite a bit of time discussing the topic. But the discussion was largely speculative at that point, based on the info that the company itself had released, and also like in a Wait But Why kind of pretty long write-up, like 40,000 word write-up. So as well as some of the progress that similar entities have made, and the progress that's been made in academia, right? Like as opposed to private companies working on these devices. And we also scrutinized the composition of the people who were involved in founding the company. And the short story was that it was really impressive. It was compelling. It wasn't, smoke and mirrors, at least at that point. It seemed like they were set up to not just be smoke and mirrors. And so, we might talk about the fate of the founding members of Neuralink a little bit later, but the short story as well. The ultimate goals of the company, producing a whole brain computer interface, are really quite ambitious, like about as ambitious as a company like that can be. The more proximal goals seem quite reasonable. Also, the technologies that they were describing weren't like particularly fantastical, right? They were just basically proposing an accelerated improvement of the kinds of technologies that we use in the lab in which I worked for my PhD. For sure, they were planning on pushing boundaries, but it wasn't like they were proposing to like build a time machine or something, right? And I remember when Elon Musk did his announcement about a year ago, a lot of the neuroscience and neuroengineering communities were sort of like surprised that it wasn't more extravagant and more unrealistic. Anyway, that's just a bit of context for my reaction to the initial launch of the company about a year ago. It was just surprisingly realistic. All right, so what's changed in this most recent presentation about a year after that initial one? So there was really one main demonstration that they did of science, at least one that was like most relevant to neuroscience. And it was a really very elegant demonstration, despite some, totally understandable and justifiable, hiccups, because they were performing their animal work in an ethical way, allowing the animals to do what they wanted to do. And so they were working with a set of pigs in whom they'd implanted some of their devices. And you can see what their device looks like right there. The device is significantly smaller than it was about a year ago, and pretty much any equivalent device that I've seen that's capable of doing what this thing can do. And so it's basically just an array of electrodes that can target specific parts of the brain, theoretically a wide variety of the brain. But the demonstration was really basically like their proof of concept with a lovely pig named Gertrude, who was being a perfect pig who happened to have a Neuralink installed targeting one of her sensory systems, specifically the sensory system devoted to when her nose or snout touched things. So they showed what's called a raster plot, which you can see here sort of. I mean, it's a little small. You can see the sort of like little dashes, little dots. Don't worry about what a raster plot is or the terminology. It doesn't really matter. Basically, every little white dash you see there is a neuron firing an action potential, or what probably most people in popular culture would just call an impulse. There's some slight distinctions there, but for all intents and purposes, they're impulses. So Gertrude the pig is poking all of the hay. You can see underneath her. There's the pig. And her somatosensory cortex is firing, neurons in the somatosensory cortex are firing to let her know that she's touching things with her snout. And then the Neuralink is showing us what some of that activity among those neurons looked like. So, they did a great thing in their demo. They coupled the neuronal firing frequencies with some kind of like musical scale. I think it might have been a pentatonic scale, but, basically whenever a neuron fired an impulse or an action potential, a note would be triggered, so you can hear it audibly. So what they did is to make that whenever there were like elevations of neuronal firing frequencies, so neurons were firing more and more, it sounded like somebody translated to like somebody playing keys on an electronic piano or something, keyboard. And it might have seemed a little gimmicky or maybe completely novel to a lot of people. In fact, neuroscientists actually do sometimes use an auditory output of neuronal firing so that we can literally hear when neurons fire action potentials, right? It's like sort of like an intuitive way to listen to what neurons are doing. And what was fun about this demonstration was that they coupled it to what I think was the overall volume of how many neurons were exhibiting increased firing frequencies. That was definitely something that I found pretty fun. I think the way they did it is like, with this much of an elevation of firing frequency, you would have one note. If it goes even higher, you have a higher note, and so it goes. And it was fun. I mean, it was really elegant. But this was really their only hardcore scientific proof of principle of the device that they presented, that they could wirelessly record from neurons in real time. And of course, we are sort of taking their word for it that it was indeed a real-time output, that it was live, truly live, and that they didn't like record the sounds previously, and basically what we heard was like an audio track, like an MP3 playing in the background. But given that there are several scientists and engineers signing on to this happening, it'd be career suicide if they were like pulling a Theranos at this moment and just like again playing a recording of what it would sound like if neurons were firing in those moments, and perhaps it wasn't wirelessly recorded. But I'm willing to give them the benefit of the doubt here. And anyways, to be clear, so far what they're demonstrating is not super earth-shattering. I mean, it's absolutely impressive, and the scientists and engineers working on this project are absolutely worthy of recognition. Just this alone is a pretty impressive, innovation on pre-existing technology. But the technology we're seeing right now has absolutely existed for years now, for quite a while. So how would I know that? well, over the course of my PhD work, one of the potential experimental designs I was considering included the use of a platform that enabled the use of wireless optogenetic stimulation and recording. And I don't really want to get into explaining like optogenetics and all that. I'm happy to afterwards. It's a simple concept, but the point is, the use of some engineered viruses that we made in the lab in fiber optics. I was considering doing experiments working with rodents, rather than pigs, that would involve basically exactly the same capabilities that they're demonstrating. Wireless recording, stimulation of neurons in animals that are fluffy-tailed and behaving totally normally and unencumbered. And I'm not 100% sure of this, but I think there's a very meaningful reason that they went with the somatosensory cortex. Rather than something, meaning like those musical sounds we heard when the pig was poking around with its snout, rather than some other, demonstration of the device recording brain activity somewhere else in the brain. So let me show you why. So here you can see at the top in the sort of darker blue color, the somatosensory cortex. And so it's like right at the outer layer of the brain, right? Like super easy to reach surgically. I mean, not that easy, but easier to reach surgically than other more, deep subcortical regions. It's not very deep in the brain, like, the target for like Parkinson's disease is, for example, which would be the substantia nigra. Quite a bit deeper in the brain, more difficult to target, I would imagine, for a device like this. But my point is, it is a cool demonstration, and it's actually... it's a rather simple part of the brain to target surgically compared to, what it will take to accomplish the rest of their goals, which would involve targeting those regions of the brain that are at least a bit, if not quite a bit, deeper in the brain. But that's okay. I mean, you pick your demonstration, has to be feasible, has to be realistic. That totally makes sense. So what are the main innovations from Neuralink that they presented last week? So I think it comes down to just a couple things. So first, miniaturization. That's really the main thing that was impressive to me that they presented. They haven't really invented a new technology. Everything they're describing exists in one form or another and is currently in use in neuroscience labs all over the country. Literally right now, I know that somebody in my lab is doing tetrad recording or doing a similar type of experiment. So, but cramming all that tech down into something that's super discrete and tiny is a feat of engineering that's quite remarkable and super meaningful. It's just that in and of itself is a meaningful contribution to the world of brain-computer interfaces. Okay, so that's the first one, miniaturization. The second one, a focused effort. So, make no mistake, there's a bunch of labs working on brain-computer interfaces for the treatment of the types of conditions that would benefit from computer-assisted, modulation of neuronal activity. But the difference is that essentially all academic labs basically have to obey the laws of publish or perish, right? And therefore the cycles of applying for funding, right? They're not generating their own revenue. It's a different model. And there are advantages and disadvantages. But if a lab isn't producing academic publications like once a year, kind of at a minimum, it can imperil the long-term goals of the efforts they're pursuing, right? Having a big pot of money that's entirely devoted to a specific effort is a different model. It's sort of like the Manhattan Project. Those people didn't have to apply to the NIH or I guess Department of Energy in their case, whatever it would have been at that time during the Manhattan Project to sustain the project, right? The funding was a byproduct of their goal and not the other way around, right? So having that concerted effort is a different model and I think really productive for something like this. Okay, so that's the second. Third, a pipeline of goals that's realistic and importantly sensitive to revenue, right? Something that I noticed early on about the company was that they do have these very lofty long-term goals, but their proximal goals, like their more immediate goals, are realistic and reasonable. They want to need to produce products that can help treat conditions that would benefit, again, from a brain-computer interface. It's a bit more sophisticated than we have now. So while they sort of couch their presentations in a lot of very imaginative and ambitious proposals, which is great and romantic, and it's sort of like part of Elon Musk's secret sauce, I guess. The reality is that their imminent goals of treating movement-related maladies are significant and more realistic and attainable. And so as a result, if they can produce a device that can treat movement-related maladies and therefore sell those products and be compensated by some combination of insurance companies and Medicare, probably, they can, generate meaningful revenue with which they can fund their subsequent, arguably more ambitious or lofty goals. So, a coherent development pipeline is number 3. Fourth, a very direct coupling of neuroscience, neuroengineering, and product manufacturing and logistics, right? So I'm close friends with engineers, and I regularly hung out with bioengineers as a neuroscientist, but I rarely really collaborated with people from either of those disciplines. I did work for a short time with a neuroscientist who has a background in engineering. He started as an engineer and then dove into neuroscience, and to be literally, he worked on a lot of the same exact stuff that purportedly has been going on in Neuralink, miniaturization of tetrode drives. Don't worry about what tetrodes are, but basically it's very making the devices that can record and stimulate neurons smaller and smaller and smaller. And he made a lot of progress over the years. It was pretty remarkable. Really, really smart guy. And to be sure, those collaborations are happening all over the country. Neuroscientists, neuroengineers working together. And I'm sure all over the world. I'm certain all over the world. But having a mutual goal to which members of both disciplines are actively working and contributing can, I suspect, have a multiplier effect over time. But particularly if it's occurring over a longer period of time than sort of typical academic cycles. So Elon Musk described just how many neurons their device can record, and it is a really big number. It's certainly bigger than my brief experience working with tetrode recording or again comparable sorts of technologies. So don't get me wrong. If they are truly able to accomplish what he's describing, it's meaningful, and it's almost certainly a byproduct of a consistent collaboration between members of related but disparate fields like neuroscience, neuroengineering, bioengineering, prototype creating prototyping, rapid prototyping, that's the phrase I was going for. So that's number 4, is this close collaboration that's sustained. Fifth, they presented the goal of developing a surgical technology that would automate a very significant proportion or component of the implantation of their device. So I'm not a neurosurgeon, but I can target regions of the rodent brain within about a half a millimeter of each other, right? So very, very small, very, very small structures to target with your hands, right? You probably think that you can hold your hand pretty steady. If you put it under a microscope, the steadiest of snipers, their hands are moving uncontrollably. It's just a byproduct of how our motor system works. Some people are a little bit steadier than others, and if you've had a bunch of caffeine, then that's gonna influence how steadily you can hold your hands. But even the most gifted neurosurgeon in the world, there's still some imperceptible but meaningful movement when you're trying to target these small brain regions and trying to not damage neurons when you're implanting something, for example. And neurosurgery is absolutely one of those disciplines that demands among the most rigorous of medical training. And there's absolutely a demand for improving upon the limitations of the control that humans have over the movement of our fingers. But the presentation of their device struck me as almost entirely aspirational. Their goal is to create a platform that's sort of like LASIK, LASIK eye surgery, where so much of it is sort of automated that it has become one of the more, one of the safer procedures one can have. There's some controversy about that, but, by and large, relative to other types of, particularly neurosurgery, having a platform like a LASIK but for brain implantation would be fantastic. So from what I saw, though, it didn't seem like they had any real demonstration of progress towards that goal, apart from what the machine might look like, which is important, but I'd love to see some innovation there. It would be a boon to all of us, and I'm glad that there's a concerted effort to create a technology like that, but I saw no evidence that the device actually does on anything other than look like a device. It doesn't mean that they haven't made it, but that's just, we can only judge using what they showed us, right? So where did the presentation leave us? So frankly, the presentation included, a demonstration of a really solid example of what's been possible for a while now. If my principal investigator, my boss when I was in the lab, really wanted to produce a demonstration like this, our lab almost certainly could have done something like this. In fact, I don't want to get into it, but we have in the past we have done something like this. The only difference was that it wasn't wireless, but it would have been trivial to make it wireless. Just, hey, we want this to be wireless. Okay, give us another 2 months and it'll be wireless. And I can tell you what that demonstration was. A little creepy, one of the creepier things I've ever done. but it worked. Controlling animal behavior, pretty wild. But yeah, but we'd probably have focused on their whiskers rather than their snouts, right? Because it's a classic thing in neuroscience to like record the neurons. Mice and rats have these long whiskers that they use to sort of probe their environment, right? Helps them to localize where their head is in their environment, because those whiskers brush up against things. Well, of course, they're not just there for show, right? Those whiskers are associated with neurons that'll fire when something touches their whisker, and you can record that. So it would have been very, very similar. But anyways, I've seen a lot of people criticize the demo for not including timelines and so on, and I'm not particularly moved by those critiques. Like, if it takes 5 years, okay, great, that's awesome. If it takes 20 years, not as great, but still really great. They're able potentially to confront these longer timelines. And Elon Musk is sort of notorious for saying, like, we're going to go to Mars next week. We're going to have a base on Mars in 2 weeks. He always does that, and, whatever. Who cares? Like, that's part of his charm, I guess. And that's part of how he attracts investors, I assume. But from our perspective, unless you're working at Neuralink or depending upon this device, who cares? There's a pretty solid critique by Antonio Regalado over at MIT Tech Review of the Neuralink demo that I do recommend checking out. It's definitely pretty critical. Like, I think it's clear that, a lot of people have this posture towards Elon Musk where it's like they're instinctively skeptical, which is good. I mean, the press should be adversarial, right? But, ultimately, here's why I'm hopeful that this team keeps moving forward. If they can, keep innovating. Oh, wait, did I? Right, okay. If they can keep innovating, and improving this device, we're going to have significantly more sophisticated tools in the neuroscientific toolbox to interrogate consciousness at the levels that are necessary to understand the nature of consciousness. And I don't remember these gentlemen's names for sure. I think it's like Max and Joey O'Doherty, I think. Obviously that's Elon Musk over there on the side, but if their overall goals, so basically towards the end of the presentation, they went member by member of the company, of the leadership of the company, saying, why are you doing this? Like, why are you here? and what they articulated was what I thought was the most meaningful from just sort of like an objectively scientific perspective. And I agree with them that basically, this technology would dramatically accelerate scientific research considerably. Being able to interrogate the brain at a far more granular level, because you can record from and stimulate a very significantly greater number of neurons using a device that has very minimal effects on animals or people, because it's so small that it basically becomes imperceptible. That would be a gigantic boon to research. And judging from my interactions with my principal investigator, a pretty senior scientist at a very large research institution, we'd have absolutely considered using a technology like this that they're describing if it were available. So if all of this is theater and bluster, if all of this theatricality is necessary for the team to produce a device that accelerates the interrogation of the neurobiology of consciousness, I'm totally okay with it. But make no mistake, your local neighborhood neuroscientists have been already doing work that looks quite a bit like this for a while. And whether it's this team or the National Institutes of Health, neuroscientists are devoted to curing the diseases that the team at Neuralink is currently trying to cure. Okay, that's what I have for you today. I really recommend you check out the presentation. It's fun, and there are some digests of the demo. But I think the presentation was actually pretty long. But the question and answers period after the demo, I think, is quite a bit more interesting. Apart from Gertrude being an adorable pig, but and the Q&A session lasts like twice as long as like the main demo. So I just recommend you check it out if you're interested in this. It's available on YouTube, and yeah, it's cool. So that's what I have for you today. All right, let's start the left half. Oh, hey, Joy. Good to see you. Hello, Hal. Good to see you. His name is Musk, Ian. Musk. What did I... Okay. Hello, everyone. My name is Ian McLaughlin, and I have a PhD in neuroscience from the University of Pennsylvania, and it has been quite a while. For a variety of reasons, not the least of which is my eye is pink. I look like Kano from Mortal Kombat. It's terrible, very frustrating. I always forget to do this, but and it's taken a while to it's still not gone. So it's taking a while. But yeah, so it's sort of like, you know, my new job, pink eye, and, you know, the baby, and just all of these things have become really, really difficult to sort of navigate and, you know, squeeze out some time for fun. But I did it today. And on YouTube, I just talked about the updated Neuralink presentation that Elon Musk and his team did about a week ago. So you can check that out, youtube.com/anthropoid, or you can just search anthropoid brain, something like that. Yeah, I mean, essentially the short story is it was a little... there was a lot of theatricality and stuff, and but it was like, it wasn't as startlingly imaginative or ambitious or really super groundbreaking, or at least not to the level that I think a lot of people expected, particularly like neuroscientists. Yeah, hello, Mary. Yeah, it's been a while since I've been on. All right, we're getting a call. Cool. Right out the gate. Okay, Catherine, I think we're connected. Is that your name? And if so, where are you calling from?
I'm calling from Florida.
From Florida. Awesome. What's on your mind?
I was just wondering about mini strokes.
About, I'm sorry, what kind of strokes?
Mini strokes.
Okay.
What are they?
Sure, yeah. So mini strokes are also called transient ischemic attacks, or TIAs. And they, you know, mini stroke is like a good name for them, actually. Basically, so first of all, what a stroke is for one reason or another, some part of the brain, or large parts of the brain potentially, have been deprived of blood, right? Really, they've been deprived of oxygen, which of course blood delivers oxygen. There are a bunch of different ways one can have a stroke, but ultimately that's what happens because neurons need so much oxygen all the time, constantly, and nutrients and other stuff. They can begin to die pretty rapidly. And so what a TIA or a mini stroke is just a smaller version of that, where the affected area of the brain is quite a bit smaller, and that deprivation of oxygen only lasts for a much shorter period of time. So as a result, one can have experienced transient ischemic attacks or mini strokes and not even know. They can happen when somebody's sleeping. They tend to happen in clusters, and they can sort of accumulate. But the main difference is that a TIA is not even necessarily obvious that it happened. It can be, though. And a stroke is more like a very fundamental source of damage to the brain. So yeah, that's essentially what a TIA is.
Thank you very much.
No problem. Is this something you're dealing with?
Well, I just wanted to know, I know someone that's having mini strokes now. I was just wondering if a mini stroke would eventually go into a regular full-blown stroke, or can it be controlled by medicine or whatever?
Yeah, so that can happen, right? So if somebody's having TIAs and then that's totally not unusual for there to be a full-blown stroke after a series of TIAs. Can they be controlled with medication? Absolutely. There are a bunch of other conditions. I mean, it can't be like cured or prevented altogether, but the frequency or the likelihood that they'll happen can be reduced significantly. So like one of the sort of classic predisposing factors to having a stroke or a TIA is some kind of cardiovascular disease. It can be high blood pressure, low blood pressure. It can be, the accumulation of a lot of plaque that can be associated with a heart attack. But one of the ways that people can have strokes is if some of that plaque that's accumulated along the arteries gets jarred loose and then flows through the circulatory system, and then eventually gets to a point where the blood vessels are so small that it can't continue moving, and then it's like a dam, blocks blood. And so the types of medications that one would take for heart disease can be preventative. So things like statin drugs can be used to treat those other things, heart disease, cholesterol, hypercholesterolemia. But that the side benefit of that is that it also can reduce the likelihood of stroke. So yeah, definitely it's the kind of thing you want to bring up, or that person wants to bring up with their physician. I'm sure they have, and I'm sure that they're on some new medication.
Okay, thank you very much.
Yeah, thanks for calling in. All right. Can you tell me about serotonin syndrome? It would be my pleasure. Alpodadon. So, serotonin syndrome, nowadays more frequently called serotonin toxicity, is it's a fairly simple state of affairs in the brain. Levels of serotonin have escalated to a point that it becomes toxic, that it induces seizures, and therefore potentially neuronal cell death. Serotonin syndrome or toxicity generally, it can arise naturally, it can happen spontaneously, but I think very frequently it can arise due to a combination of drugs that influence serotonin levels. So like if somebody's combining MDMA and some other serotonergic psychedelic or stimulant, because it's sort of like how the combination of benzodiazepines and alcohol, or benzodiazepines and opioids, is significantly more dangerous than either drug alone. And that's because there is this kind of multiplier effect. It's called potentiation of the effect, right? Where the effect on serotonin levels, or in the case of benzodiazepines and alcohol or opioids, the combination of those two drugs is greater than the sum of its parts, right? Because you're stimulating the same receptors in different places, and it generates an even greater response of the receptor to the drugs. And that's why people can die of respiratory failure using doses of either drug that would normally never be a threat to them, particularly because they'll usually have a high tolerance when they're combining those types of drugs. But that's, a lot of celebrities have unfortunately passed away from that combination. When it comes to serotonin toxicity, it's a similar kind of an effect where you have two drugs, both of which are elevating serotonin levels by different mechanisms, binding the serotonin, or acting as a serotonin releasing agent, right? Where it's just stimulating serotonergic neurons to release more serotonin. And then another drug might be inhibiting a reuptake protein or reuptake pump that is responsible for removing serotonin from the synaptic cleft. And so you have like a double whammy, and then serotonin levels can escalate and then result in a seizure, and it's extremely dangerous. Okay, how can we replenish serotonin in a healthy way? Well, certainly if somebody's been doing serotonergic drugs, again, like MDMA or whatever, like halogenated phenethylamines or those types of drugs, stop doing those drugs for at least a while. That would be like the first thing. The second thing is to make sure that you have a reasonably competent diet. So serotonin is synthesized from an amino acid that you get from your diet, tryptophan, and so if all you're eating is bagel bites and Cheetos, you are getting some tryptophan, but not what would be considered an optimal level, I would argue. And just sustaining a sort of healthy lifestyle for longer than just a day or a week. It's I think that there's a bit of a misunderstanding that we can control. We can selectively control dopamine levels or selectively control serotonin levels. You can influence those things by diet, by exercising, doing things, cuddling can elevate dopamine levels, right? But the synthesis of those neurotransmitters is not under your conscious control, right? You can't it's not like meditating and repeating certain mantra will selectively elevate serotonin levels. Serotonin levels will change, but they're changing right now through us just having this conversation. So rather, it is just a sustained sort of healthy lifestyle that is really the best way forward. If you are concerned that you have, for some reason, serotonin depletion, which you probably don't, The reason that people feel sort of bad after pharmacological experiences like this isn't just a byproduct of too little serotonin. It's an acute withdrawal reaction where, at levels of serotonin, let's say, or dopamine is really probably more what's guiding the negative, feelings that people have. The levels of those neurotransmitters, the release of those neurotransmitters has been elevated for so long that then the pendulum swings in the opposite direction. So it's not like you don't have enough serotonin available. It's just that less is being released because the volume was turned up so high for a while there. So it's not like, certain things can selectively influence serotonin levels apart from eating tryptophan, but rather it's letting the brain do what it evolved to do. Yes, Neuralink for the win. I think you called in. Feel free to call back in. I talked about the new Neuralink presentation on YouTube, youtube.com/anthropoid. Oh yeah, here we go. Cool. And hey, Leonora, good to see you. Sorry, here we go. All right. It looks like we are connected. What's your name and where are you calling from?
Hi, I'm Shauna. I'm calling from Las Vegas.
Shauna from Vegas. What's on your mind?
I have questions about Neuralink. How do you feel about it? Like, do you feel like the implications of Neuralink going into the future are going to be mostly positive, or do you feel like there's going to be like a great divide between people voluntarily wanting to get it?
Yeah, I mean that is for me that's like the fun part of Neuralink. So I did, I have a podcast called Wired to Be Weird, and we like really went deep on that part of the whole brain-computer interface, the prospect of whole brain-computer interfaces. The short story is, when it comes to science and like philosophy of science, particularly neurophilosophy, I kind of hesitate to ever make a kind of value judgment on a technology. Rather, it's like this kind of a technology is going to exist in the future, whether it's Neuralink and Elon Musk or some of the other companies that exist today that are working on that kind of technology. It's gonna exist. So, it's gonna have positive and negative consequences, just like the internet had positive and negative consequences for human society. This will have both. There are some risks that are unique to Neuralink, but I think it's somebody would be hard pressed to successfully argue that having the ability to intervene in the brain in a very targeted and precise way isn't worth it or is bad. It will render us vulnerable to various molestations of consciousness, but overall I think it is very positive. But the other thing that you brought up is I think something that isn't discussed very much in this topic, which is yes, I mean there is inevitably, like all technologies, there inevitably will be a division of people who don't want it versus those who do, but B, those who can afford it and those who can't.
Yeah,
right.
That's what I'm scared of too. Is it's going to become like an elitist sort of like divide of who can actually get Neuralinks, get upgraded Neuralinks, and then is going through life with all of those tools Neuralinks kind of giving them, because there's going to be recreational, abilities that are going to be on the Neuralink I can't even like understand yet.
Yeah. I mean,
people who are not going to experience those things are going to be at a total loss.
But yeah, totally. But I mean, even for things that for financial reasons, like imagine if you are an investor on Wall Street or something, and right now they rely a lot on algorithms to do like super microtransactional trades, right? So the computers are largely handling this. The human brain just isn't fast enough. The human fingers aren't fast enough to like keep up with computers. But imagine if you had access to like computer assisted cognition, right? Where you can just do calculations at like just such a faster rate. But
there'd be a group of people that are like sentient. Where did the civil rights come in at that point?
That's right. That's right. I mean, also, yeah. So just like CRISPR, I think is a kind of comparable kind of like.
That too, gene.
Yeah, right. That sort of is kind of gonna redefine how humans reproduce, and fortunately for us, some of the inventors of that technology, namely Jennifer Doudna, who's a brilliant, she's gonna get a Nobel Prize, and she's quite young. She has been very meticulous and cautious about saying, these are the risks that my baby, my technology can present to us, and this is why we need to be careful. I'm not so sure that I trust Elon Musk is quite as cautious. He strikes me as more of like a Silicon Valley type, move fast and break things type of thing. And so, that's a concern for sure. And then also like people who, a device like this, one of the things that I complimented about the company is that they have these lofty, ambitious goals, like what we're talking about, right? But their more proximal goals are pretty realistic. Like they want to treat movement-related maladies. Boom, that's it. And that is totally possible. Like that's possible today. And it's just that we don't have a device that's quite as sophisticated as what they're presenting. But so imagine, you are suffering from Parkinson's disease or something else like that, and your insurance company isn't going to cover this device. Well, some people are going to be able to pay for it. So somebody gets into a tragic car accident and they'd otherwise be totally paralyzed were it not for them being able to shell out $2 million to get this thing implanted, right? So I think that there are definitely societal consequences, ramifications that are worth contemplating. But super interesting topic.
What do you think about if we light up sort of more ambiguous parts of the brain that we've never lit up before with Neuralink?
Well, so I wouldn't think about it that way. There's no parts of the brain that for which we have no knowledge, right? We have no knowledge what they do. There's still a lot to learn. Don't get me wrong. What I did for my PhD was that kind of work, but it's not like there's this abandoned lot within the brain where our searchlights can't go yet, right? The way I would think about it rather is that you will be able to intervene in neuronal activity in a way that is inaccessible to us today. So it'll be more like it's going to grant us access to a wider array of capabilities than exists today, rather than like giving us a whole complete new capability, right? I don't know if that makes sense, but it's going to enable us to ask.
There would be a way for it to like increase our brain capacity that we use at any given time, even if it's just like you know what I mean? Like
yes.
I feel like.
Yeah. No, I think that's exactly right. Yeah, like for sure, that's true. I'm talking more about just from a scientific perspective. Like, what are we going to be able to do with this device to understand the brain more? What it's going to enable us to do is ask a wider variety of questions more precisely. But what you're talking about, imagine when was the last time you memorized a phone number, right? We've just sort of like totally offloaded that cognitive responsibility to our phones, to computers. We're totally going to be able to do that. We would be able to do that with a device like this. But again, that's way off. That's not even in the next 5-10 years. I don't think. I mean, that's when the device becomes that sophisticated, you and I are going to struggle to even remember having this conversation.
Yeah. But I mean, what if there are people who are like jailbreaking Neuralink chips or some shit, and there's like a black market of people who are like lighting up just their serotonin receptors, or like or like
totally.
Some kind of recreational use of like skewing the Neuralink to be just ridiculous.
Totally. Well, so there's two things there, right? The first is just like, let's say I have a Neuralink, and it is, this is now 50 years in the future, and the device is like really, really sophisticated and effective. Well, then, yeah, I mean, I could theoretically just like sit in bed and tickle my dopaminergic, serotonergic neurons in the way that a combination of cocaine and heroin and would do, and you just be there like drooling, right?
That would be crazy.
Yeah, but the other prospect that I think that brings up is like all computer systems are vulnerable to manipulation, right? And so on the podcast, I talk about a scenario where imagine you have this device and some, malicious actor somehow hacks your device. I'm sure they're going to have security and all that kind of stuff, but anything can be hacked, right? And so imagine that you do have this whole brain-computer interface. What could you do with somebody if you had access to theirs? Well, you could make it so that every time they, throw an axe at somebody, they get their dopaminergic receptors are tickled, right? They get reward, or they have an orgasm every time they do that.
Wow.
Then all of a sudden you
could like condition someone's mind completely different.
Exactly.
Wow.
So, but let's take it even a step further, right? your desires, your aspirations, your beliefs are all engendered within the brain. And so you could theoretically not even be that crude, right? You could just make someone all of a sudden feel like they need to blow up, the skyscrapers in Center City, right? And they it's not like they're getting this pharmacological reward. It's not like they're feeling like they're doing drugs. Rather, they all of a sudden now truly believe and are motivated to commit these atrocities. Yeah, so like it's scary. I mean, another thing, here's another sort of nightmare scenario. Again, this is speculating on the device that does not exist today, and it probably won't for a very long time. But once it does, your movements are all regulated within the brain, right? My decision to scratch my eyebrow right now, that was exclusively created within my brain. Well, imagine that somebody, again, hacks into your Neuralink, and now they have complete control over your motor system. So you could just be a prisoner of your motor system, where you can see yourself doing all these things. You're horrified by it. You're screaming on the inside, and there's nothing you can do, right? You're still going through the motions of putting a bomb at the bottom of a building.
Sleep paralysis.
Yeah, right. Like, totally. Yeah. So, I mean, these are all things that, again, they're not something we have to like imminently worry about, because it's not even close to that point yet.
Right.
But at some point, I would argue that these are things that we have to prepare for.
Well, I would hope that we would put things in place to sort of deter away from like dystopian scenarios.
I would hope. I mean, frankly, I'm not particularly optimistic, given how the U.S. government, at least, has dealt with Silicon Valley, right? I mean, you have these what are essentially like financial warlords. They've generated so much revenue, and there's really been like very little regulation or preventing, these companies from affecting our lives in deleterious ways. So, and it's not like politicians are sort of notorious for being particularly scientifically literate, and so yeah, listen, I hope so. I'm totally with you. I hope that we get there, and hopefully, people like me or, much more senior scientists will be able to participate in developing a sort of like bill of brain rights, but yeah, I don't know. It's fun to.
There needs to be like AI rights or like a bill of brain rights or something.
Totally.
Or like there's going to be people walking around with Neuralinks and people not with Neuralink. There needs to be a way for people to identify like if that person has a Neuralink, because that's even kind of freaky if like they're just walking around and you don't know if they have a Neuralink. I don't know.
Yeah, totally. But then again, hey, I mean,
2 or 3 Neuralinks.
Well, that is one of the things that they described in the presentation. But I mean, we're currently living in that world a little bit. Like, people are walking around with cameras. They can put them anywhere, and you have no idea that you're being recorded. So I mean, that is the world in which we're living. And so I mean, it's great to contemplate. I'm glad people are thinking about this at this degree of depth. But yeah. Anyways, thanks so much for calling in.
Yeah, absolutely. Thank you.
Shauna from Vegas. Oh, wait, yeah, we have other callers. Let's just get that. Oh, we have Abyss calling. We are fortunate. Hopefully it connects. How have things been? You seem tense today. Okay, I mean, I talked a little bit about it on YouTube. It's been rough. Everybody is struggling with the pandemic right now, right? We've done, our country has, I don't know if you're in the United States, but if you are, our country's done just an abysmal job, just absolutely failed, remarkably. And the reason it's so frustrating to somebody like me is, as somebody who was in biomedical science, like, just watching, it was just baffling, unimaginable that there wasn't a test for the virus, like, immediately. Like, yeah, and it's very frustrating because I have a 1.5-year-old, or a daughter who's about 1.5 old, a little bit older now. She'd totally be in daycare by now, interacting with other babies, learning from them, scraping her knees when she's like chasing the other baby, just doing the things that babies do, that little human primates, right, have to do to develop social skills. And she's been deprived of that. We're working on trying to make some kind of replacement for that with other families that live near us with equivalently aged babies. But I think that there will be PhDs that will be written on the effects that the failure to confront COVID-19 in this country have had on a generation of people. Not just babies. I mean, high schoolers aren't getting into trouble, doing the things that high schoolers have to do to mature. It's very, very worrying to me. It's disturbing, but, it gotta confront the world on its own terms, right? Hello, can I join and ask a question? Oh, wait, oh no, Abyss. Here, let's see if we can talk to Abyss. Oh, great, it looks like we are connected. So Abyss, I won't ask what your name is or from where you're calling, but everybody, know that I've known Abyss for a while. So what's on your mind, man?
Hey, how's it going?
Good. Well, sort of.
Well, yeah, I know. Yeah, I'm really glad that you're talking. I mean, you're just like setting aside some time to talk about Neuralink. Yeah, it's just probably gonna, probably I can delve into some more detail than the usual conversation. So just fair warning.
All right, I'm game. Let's do it. Everybody brace themselves.
Right. So, do you think recording from multiple channels is a good strategy to go as opposed to, having fewer channels and from local field potentials, unlike what Neuralink did? Because if you have, it's really important to record from every neuron, every potential neuron. But I see a downside to that because they use threads which are even finer than tetraodes, right?
Yep.
Which means that they don't have high impedance. So just wanted to know what you think of that. Do you think it's there should be a trade-off as to how many channels that you should record to that of what's the signal fidelity that you could possibly get?
So basically, like,
Does that make sense?
so the trade-off of like recording field potentials rather than single units, is that?
Exactly.
Yeah.
Yeah.
So basically, what just so everybody's on the same page, this is like the nitty-gritty details of like how a device like this works. So to give you all some context, when you're saying field potential, you're sort of recording from a bunch of neurons in an area, right? So it's sort of like, rather than, imagine you're trying to figure out what people are talking about in a bar or something, right? You could go in to the bar, just open the door and just like listen to the sort of overall chatter of all the people in the bar. Or what you could do is go one by one, to each person, listen to what they're saying, and then you'll have a much more granular, arguably more accurate representation of what the conversations were going on in the bar. But it's harder, right? It's more laborious and riskier. Maybe one of them's going to punch you. I guess that's the equivalent of like if one of the electrodes breaks or something, which totally happens. When I was doing tetrode recording, like we would lose 4 channels, and so yeah, so I am sure that that's something that their engineers have confronted. Ideally, you would want as many, recording the finest resolution you can possibly get. So yeah, that would be my guess. Also, I would just imagine that the volume of data that they have to like navigate if they were doing like single unit, like an array of single units, that it's probably unmanageable. So I would imagine that's the sort of trade-off. I mean, in terms of like the efficacy of the device, you're definitely not going to have as effective a device relying on field potentials, but I think that's probably the trade-off. It's more of like a feasibility type of situation. I suspect. I mean, honestly, I have no idea. Obviously, we did tetrode recording, so we went for a finer resolution. But as you were saying, tetrodes are quite a bit bigger. They're super irritating to have to make. So yeah, I would imagine that's the trade-off. But honestly, I'm not sure. So are they doing? I'm trying to remember how they set it up, but I think he said they can record like 1,024 channels. Was that the number?
Yeah, that's right.
Yeah, that's a lot. I mean,
It is a lot. Yeah.
Yeah, I mean it's, but as I
If you saw the rasterization, you can actually see single
Yeah.
wiring.
Right.
So, I'm guessing that they either have like a very good classifier, like onboard classifier that does, that
Can identify.
single units for them,
Yeah.
right? Or, yeah.
I bet that's what they were doing. That whole, like, I talked about that a little bit on the YouTube. Like, first of all, we're sort of taking their word for it that wasn't, they weren't just like playing an MP3 file, because, like, Pig is just constantly bumping into things, and, like, it's not like somebody's gonna be sitting there and it's like, oh, there was the note and there was the touch event. So
Also, I think the snout is probably the most innervated area. So
dude, totally. Not only that.
Stuff else, so it's easier to map out.
Totally. I mean, not only that, but they were targeting the somatosensory cortex, which is like,
Exactly.
it's like a very easy. It's exactly what I would have suggested if I were on that team. Much lower probability of failure. Your electrodes probably aren't going to break or miss because they split. Well, whatever. So yeah, everything about that demonstration was I think most neuroscientists watching it were like, we could do this. Like, it wasn't earth shattering what they were doing. It was an impressive feat of miniaturization, and that's a lot of channels if they're really able to do that. And I bet you're totally right that they are somehow interpreting their electrophysiology to identify single units. I don't know. I would imagine because they have so many computer scientists on that team.
So technically, if I can recall some of the details from their
Demo.
From their announcement, that they used 20 times that of like the single firing rate of sampling rate. So that's like much higher sampling rate. So they're literally their device is actually inundated with lots of data.
Yeah.
So I'm assuming that they can do this, like, at least like the classification is they said that they use onboard classification. They don't export it to a device like cell phone or computer. So with that in mind, that they need to have like much faster classifier on board, and I think that's actually the novelty of the work, if I should say so. Like besides the design of the threats.
Totally.
That
Yeah.
they talked about. Yeah. But also, I guess like this is kind of a trade secret, but I mean, we all know like how electrodes eventually degrade over time.
Mm-hmm.
Right?
Yeah. Yeah.
Right, and that's the part that really trips me up. Like they didn't talk about the shelf life of the electrodes within the brain.
Didn't they? I think didn't they say that they apply some like coating to them that makes them the degradation like minimal?
Well, you can apply polymer.
Right.
Coating. Like that's actually the normal practice. So
Totally.
if you're talking about Utah array, for example, you normally apply some kind of coating.
Yeah.
Polymer.
But so that I would imagine that they have some. I bet it's not like super robust demonstration, but I'm sure that they have some kind of coding that they're confident in, whether or not it does sustain the integrity of the electrodes for longer. I don't know. They're not publishing. But anyways, yeah, no, I totally agree.
Right, and also I don't think they're kind of a continuous depth, if you will, unlike tetrodes. So if you have tetrodes, you can essentially detect signal from any depth. So I believe that they have like a bead kind of structure in these threads, and that's where I mean my guess is that they're probably using those beads. I mean the bead structures to essentially reduce the impedance of the detectors. So, I mean, this is just like my own observation. They didn't talk about that in detail.
Yeah.
But yeah, I don't know. Like, I mean, it's interesting. We discussed this before. I find it to be interesting. I'm a little skeptic because they didn't have any published data for that, and I can understand why, because it's a trade secret.
Yeah.
But also, I would rather see it work.
Yeah.
Because
Yeah, man. Yeah, totally. Yeah. Well, listen, man. It's always a pleasure to talk. Thanks so much for calling in.
Yeah. All right.
Talk to you soon.
Bye.
It's Abyss, everybody. In case it's not obvious, Abyss has a background in engineering. Okay. On YouTube, Frank. Hi, Ian. Curious what emerging technologies you're most excited about in neuroscience and neurobiology, near or distant future. Oh, man. And hey, what's up, Oleg? Good to see you, man. Hope all is well on your side of the planet. Well, there's a bunch. Like, okay. So in terms of like, oh, weird. That's too bad. Why? Okay, sorry about that. Hopefully that just resolves. So in terms of like technologies that'll be used in basic neuroscience research, one of the most important, I think, will be for like the very near future is going to be the use of organoids. I think I discussed this a million years ago, the last time I was live, which is basically like, when you're trying to understand the biology of schizophrenia, for example, there are a couple different ways you can do that. You can study people who have schizophrenia, obviously. You can study animal models of schizophrenia, right? Animals that have some of the same genetics that we find commonly in people with schizophrenia. And then you can also study cells in a petri dish that are derived from somebody with schizophrenia, right? To understand the differences between those neurons and somebody's neurons from somebody who doesn't have schizophrenia. So the problem they all have very important roles to play in neurobiology and in research. But the problem with studying neurons, and when you study the neurons in a petri dish, you're able to interrogate the biology of schizophrenia at a much greater degree of depth, right? You can study the genetics, you can study the morphology of the neurons, you can study, protein synthesis in the neurons. All of these various things that you just can't do just by like talking to somebody with schizophrenia, right? So, but the problem is that those neurons, when they're sitting in their petri dish, are in a totally foreign environment relative to what they would be in the brain of somebody with schizophrenia. Neurons interact with one another, they affect one another, they can release, exosome, they can like influence each other's, genetic activity. And so it's just different. And so you're missing out on some of the details. You're studying these neurons to get an idea of what they're like naturally, but they're not really doing what they would naturally do. Okay. Organoids is a technology that will enable us to take those neurons from a petri dish and put them in an environment that's a lot more like their natural environment. So you're seeing them behave in ways that is much more similar to their natural behavior or activity. I think organoids are going to be really important for a variety of things. There are a bunch of technologies that Carl Dieserath is working on. I think he's still at Stanford. Like one of them is, of course, I'm forgetting the name of it now. Come on. It's like the... Of course, I've just been saying the word Neuralink so many times, that's all I can think of. Basically, it's just like a new type of electrode that enables recording from a really wide array of specific neurons. That's very, very useful for all the reasons that Abyss and I were just discussing. And you can, come on, what is it? It's like a neurochip or something like that, neuroprism or something like that. And you can implant an array of these, and it gives you like just dramatic increases in the number of neurons with which you can interact. So that's good. That's a good one. I think that there will be interesting innovations on the applications of optogenetics and chemogenetics. So these are technologies that are really exclusively used for basic science right now. I used both of them in my research. Basically, what they enable you to do is to remote control neurons in a living organism. And so you can see what happens, like, hey, what happens if I stimulate only the dopamine releasing neurons that only have a certain receptor, the 5-HT2A receptor, and only stimulating them at this frequency. What happens to behavior? So you can ask those questions that you never could before optogenetics. Optogenetics has been around for a long time now, though. Well, a relatively long time. But what I bet we're going to start seeing a lot more is the use of optogenetics-like technologies to study cancer, to study or to treat cancer potentially. To interrogate a wider variety of biology than just neuroscience. So that's going to be fun to watch. Of course, CRISPR-Cas9. I mean, CRISPR is a transformational technology that enables us to interrogate genetics at, in a far more precise way, in a far more efficient way. But it's also going to yield, it's almost certainly going to yield treatments for things like cancer, and other, maybe, diabetes. So, certain kinds of diabetes. Thank you so much for the super hearts. Oh, thank you, Joy. That's very nice of you. But yeah, thanks, Jenny. So CRISPR is transformational. I feel like, the other day I was thinking about this, like, if somebody asks this specific brings this specific topic up, I should like write them down. I've been meaning to write them down for a while, because every time I'm finished on this topic, I always think of like 4 more that I failed to recall in the moment. Whatever. I'll keep the sort of those gears turning in the back of my mind as we move forward. What's up, Oleg? I feel concerned a technology like that will be used as a predictor to judge and potentially alter people fundamentally. You fit the predictive profile of X, we are going to change you. False guilt. Minority Report, right? I mean, that's basically what you're talking about. Totally. Potentially. Yes. I mean, so something like Neuralink. I assume you're referring to Neuralink. Something like Neuralink will open. We're currently suffering from a failure of imagination. As imaginative as I can be, right? As fanciful as we can all be, when it comes to like science fiction and that kind of stuff. We're definitely going to be suffering from a failure of imagination, just because we couldn't conceive of how this technology is going to affect us. Why is this being a problem? Sorry, guys. Okay. Is it possible to purposefully induce psychosis? Well, yes. I mean, it sort of depends on how stringently you're defining psychosis. But I mean, there's one particular super easy way to induce psychosis pharmacologically. You can induce psychosis using a bunch of different types of drugs. Like, probably the easiest one, or the simplest one, would be something like LSD or psychedelics. It's not, and when I say like how stringently you're defining psychosis, I mean like that's not like true psychosis, but it has a lot of elements of psychosis. For a while, amphetamine. So amphetamine is like the active ingredient of Adderall, and it's also a recreationally used drug. It's a stimulant, psychomotor stimulant, dopaminergic stimulant. And for a while, amphetamine was called a psychotomimetic because high doses of amphetamine can induce, and methamphetamine can induce psychosis, like legit psychosis, paranoid delusions, that kind of stuff, hallucinations. So that would be like the easiest way. Another way is to, suffer from severe sleep deprivation that can ultimately produce psychosis. I mean, there are symptoms of, after somebody's been drinking a lot of alcohol for a long time, they can develop something called Korsakoff syndrome, which it's not like what you would think of for psychosis, but it is like an altered state of consciousness that arises from a deprivation of vitamin B12, I believe, that is due to how alcohol affects nutrient absorption. And we're talking like a lot of alcohol for a long time. And Korsakoff's patients will exhibit this like really wild tendency called confabulation, where they're lying, but they don't think they're lying. They're just like totally fabricating answers to questions, but they're not intentionally doing that. That can happen in like some stroke patients and dementia patients as well. But there are a myriad of ways to tweak the brain in this way or that, and you can end up with psychosis. Obviously, PTSD can result in psychosis. Bipolar disorder can. Right. Okay. This is long overdue. I'm a rocket surgeon. Ask me anything. Cool. What kind of brain? Human, mouse, cat, rat? For now, I'm pretty sure I have a human brain. For now. Okay. Tryptophan, 5-HTP, serotonin. Yes, those are all related. 5-HTP is like a modified tryptophan molecule. Tryptophan is an amino acid that's used in the brain to synthesize serotonin. I heard green tea has lots of tryptophan. Maybe. I mean, you might be thinking of it's not thiamine. Come on, what is it? It's whatever. It's a different amino acid. Yeah, and there probably is tryptophan in a lot of different kinds of teas. But if you're like trying to get probably like a really efficient source of tryptophan, eating protein is probably the best way. Okay. Caller, impatient caller. Thank you. Okay. Oh, Scott. I doubt that's the person to whom my friend here was referring. Scott, in Ohio, I assume. What's on your mind?
Yeah, hey, how are you doing?
I'm okay. Can't complain. How about you?
I mean, everything's tough for everybody right now, so.
Yeah.
I mean, so real quick story, then I'll get out of the way. This is kind of like adjacent to what you're talking about, where you mentioned the idea of uploading your consciousness into a computer. Like that's been a trope of science fiction for, I don't know, probably 100 years now.
Sure.
And it's really popular. It's a cool idea, and I used to think it was cool too. Until I think I'm pretty sure it was you that one day said, well, yeah, that'd be great, but then you just have a computer that thought it was you, and you'd still die.
Yes.
It was like the little brain exploding emoji. I'm like, oh my god. So now I tell it to people, and they just don't get it. And I called into the radio show here in town. They were talking about this guy is like obsessed with Elon Musk, and he wants to upload his brain so he can live forever. And I'm like, dude, you realize you're still gonna die. You're just gonna have a computer that thinks it's you. He's like, that's cool with me. Like, you don't get it. You're still gonna die.
Yeah.
Like, so frustrating.
Yeah, you're totally right. I mean, I it is kind of hard. It's so unintuitive to like try and imagine what it would be like, but it would be more like cloning yourself or having a kid. Like my daughter has a whole lot of my genetic material. We're more similar than pretty much any other two people other than identical twins. But it's not like I can't tap into her consciousness just because we share that genetic material. So when you upload if we ever can upload our consciousness to a computer, yeah, it's just like at that moment you are now two people that have very little to do with each other apart from the cognitive similarities. Yeah, that's awesome that you called into a radio show to talk about that. That's awesome, man.
Yeah, I had to set him straight. It's kind of so thanks for that.
Hey, so before I let you go, I've been meaning to tell you about this. So I saw at my local beer store this like ridiculous looking beer, and it had been there. It was flying off the shelves, and I'm a bit of a beer nerd. Whenever that place has had Hetty Topper before, the Pliny's, they've had it, so they do get some pretty rare beers.
The elder or the younger?
What's that?
The elder or the younger?
I think it was the elder.
I was just making a philosophy joke. I didn't realize it was actually a different beer.
Oh yeah, that's funny. Yeah, no, there's Pliny the Elder and Pliny the Younger. They're both IPA. They're very, very good. They're from the Russian River, whatever. So this beer is called Sour Me Unicorn Farts, and
Oh yeah, cool. I got a bottle or a can in my refrigerator.
Oh seriously? Oh cool.
Glitter in it.
Yeah. I think it's like edible mica, and I haven't tried it yet. But okay, yeah, I guess I shouldn't be surprised that you would know about it. But anyways, I'll let you know what I think when I try it.
Yeah, my friend he works at this distributor. He loves it, so he loves sour, so he got me a can. I haven't opened it yet, but they did have it on tap at the bar, or one of the bars I went to, and people were saying it was it's edible glitter. And I'm like, well, it's gonna pass, and then you're gonna find
Yeah.
I mean, glittery poop. Sorry.
Yeah.
I got the word. But it's yeah. I had a couple more that I was trying to find some of the Belgians that they're bottling here at the local brewery, so I can try and snatch them up and and save for you if I ever get to come out again.
Yeah.
But I don't know.
The world.
It'll ever be.
Yeah, gets back to normal at any point. Yeah, well, the owner of the proprietor, dude is a huge beer nerd, right? Obviously, right? That's his job. And I was expecting him to be like, "Oh, seriously, dude, you're buying this gimmick?" And he was like, "That beer is legit good." So I was like, "Okay, Let's go for it. Well, anyways,
I wasn't already like 6 beers in. I mean, small ones. I'm not an alcoholic. I just take little samples of everything.
yeah.
I was done at that point of the night.
Yeah. Well, listen, man, awesome to talk to you, as always. Talk to you again soon.
Take care.
Likewise. All right. Now, who in the world? It's a great discussion. Catch you soon, hopefully. Bye, everyone. See you later, Abyss. Talk to you soon. So, who in the world? I think we're connected. What's your name and where are you calling from?
Hey man, what's going on? My name is Who in the World, and I'm calling from Jordan, the Kingdom of Jordan, on the other side of the world.
Oh, cool. All right. So, what's on your mind?
Well, I mean, I'm a big fan of Elon Musk. Obviously, a lot of people in here talking about Neuralink. I get it. I guess I wanted to know what your insight is more about, like, where we're headed as a society, especially for me, because, like, for example, I start my doctoral program in May, and, as we advance, it's kind of funny because many years ago, Sylvia Brown, the psychic, was on Montel Williams, and she said that we would get to this point. Not to say that I'm quoting Sylvia Brown right now, but I just remember it. She says that we would get to a point where we could basically just download books into our brain, and it made me really realize that actually that education as a whole, in terms of how it has been for however long, is going to be facing change, much like the automobile industry, much like everything else around it. And as people, we've always been conditioned in a certain way where, we pick up language, we pick up behaviors, we pick up culture, we pick up all these things. Now all of that can be picked up. Obviously, we still have the stimulus that happens between person to person, but a lot of that can just be downloaded. It's not quite the same as humans have been conditioned, but this is just a much more advanced, expedited way, huh? But will this also get rid of it? And will this will evolve education as a whole, where it might make it obsolete as we know it in terms of how we think of it? I don't know.
Yeah, well, I mean, so right now we're talking about what Neuralink might look like or something like Neuralink might look like in 50 years, in a very long time. Well, it's not next year, right? One of the things I liked about about Neuralink overall is that they have a sort of a coherent pipeline of goals, and their more imminent goals are to treat conditions that are totally treatable, like that. If they can make the device that they're describing, they could theoretically treat and cure these conditions. But, and it's the more ambitious goals that are kind of more fun to talk about, but they're not in the near future. But all that aside, yes, I mean, assuming that this technology does come to fruition, you're right. I mean, it will fundamentally redefine how humans interact with one another. Like, language completely revolutionized human society. Actually, I talked about that last week or a couple of weeks ago on YouTube, like how it was that language ever evolved in the first place and why it hasn't really evolved to such a degree in other primates. But, and so without language, I mean, I doubt that we would be interacting with one another, on any kind of technology, let alone, living in cities and stuff like that. So, yeah, I mean, this kind of, and one of the reasons that language was so transformational is that it was a far more efficient way to convey thoughts to one another. Thoughts, feelings, experiences, lessons. Something like Neuralink would expand that bandwidth so significantly that's what I mean. Like, we are definitely going to be failing to imagine what it's going to be like. So for example, like right now you have to deal with me using words to express my thoughts about this topic. And it's more efficient than just looking at my face and trying to see what I'm trying to communicate. But rather than waiting all the time that it's taking me to say these words, I could just in one moment, like, just convey to you a thought, and it would just, manifest within your consciousness, and you would not only understand, but the depth of your understanding would be so much greater than I am able to express to you using language alone. And then, yeah, like totally, learning new skills, all that kind of stuff. I mean, there are some skills that require the movement of the body to, be learned, right? Like a martial art, let's say, or dancing. But having a deeper understanding of it, before you even start that, certainly would expedite that process even. So yeah, I mean, I think that's correct. It is going to revolutionize. If we ever get to that technology, it'll revolutionize how we interact with one another.
I just want to. I work as a school counselor in international schools, so I deal a lot with rich kids who, struggle with learned helplessness because they've had, nannies and all of this stuff. But I've also worked in inner cities, so I've seen anxiety. Let's just say math anxiety, whatever. At the basic level of where Neuralink is right now, and from what their goals are, even if anybody were to if just a person were to put it in, and it just dealt with anxiety alone, the ability to really problem solve every situation would boredom would be resolved. Like if you were reading a book and you suddenly got every anxious situation that would fire off some stress hormone, which would allow you to just give up, could be resolved. Do you realize how much dreams could be accomplished?
Yes, absolutely. I mean, so I did my PhD focused on mapping out part of the neurobiology of anxiety, in part for that exact reason. Like, we are struggling with this pretty ancient organ, the brain, that evolved over it evolved over millions of years, but it hasn't really changed for the past 100,000 years. Maybe it's changed subtly, and let's just give me 50,000 years. It almost certainly hasn't evolved much over the past 50,000 years, but human society sure has, right? And so as a result, we're dealing with this organ that was sculpted by natural selection of animals, of primates, whose primary concerns and life governing goals were getting food, avoiding predators, avoiding damage to you from other humans or whatever, and reproducing. And that's pretty much it. Right? But those same, it's remarkable, but those same capabilities are being applied to a completely new set of daily concerns. And so inevitably there are going to be examples where these things are not congruent, right? Where this ancient organ is dealing with novel concerns by which that have not sculpted it through natural selection. There just hasn't been enough time. And so as a result, yeah, anxiety, I think, is absolutely one of those examples where it's very rare that we have to run away from a lion on the savannas of Africa these days, right? But it's the same machinery that is being triggered when a student is asked to read in front of the class, or is suffering from anxiety for all of the various things that come up in school. So yeah, 100%. That's why I studied what I studied.
At that level, you know what I just realized when I was let's just say what you mentioned with the student standing up, because I'm dealing with this every day.
Sure.
If let's just say a student is standing up in class, let's just say a student reading, let's just say anybody, what you are dealing with is mastery upon mastery upon mastery in each individual moment that is endless. That is just so actually what you really resolve, what you've addressed, is the issue of just mastery.
Sure. Yeah. Yeah. So hey, are you studying education? You said you were about to start your doctoral program.
Yeah, I'll have a leadership in schooling.
Ah, interesting.
Mine is more in the aspect of because I've taken some years off to meditate. I've done some sabbaticals in different parts of the world, and mine would be much more on mindfulness.
Interesting. Awesome. Yeah, I'm a major proponent of mindfulness meditation. Well, listen, man, who in the world? It was a pleasure talking. I hope all is well over in Georgia, and hope to talk to you again.
Jordan.
Oh, Georgiana. Where in the world?
Jordan, the country.
Oh, Jordan. Oh my. Sorry. That's my fault. 100% my fault. Gotcha. Jordan. Oh, sweet. Yeah. Yeah. Regardless, hope all is well in Jordan. And hope to talk to you again, man.
All right, cheers.
Take it easy. Jordan. That's a place I've been wanting to visit for a while. Okay. Speaking of mastery, is that 10,000 hours notion correct, or does it depend on the task? Depends on the task totally. I mean, there's definitely something to it, right? I mean, just repetition, practice, having a well of experience. 10,000 hours is sort of just like a convenient number, but yeah, there's something to that for sure. All right. Too much weight on words. Okay. Do you see any long-term cognitive effects from the smart helmets our forces use in combat? Ew, yuck. That's the screen name, or the handle. I knew that there was an effort to develop like helmets that can detect a potential traumatic brain injury, or TBI. I don't know about which ones are in use, if they are in use by the military. But the long-term consequences, if you mean like deleterious or like negative long-term consequences, like from that perspective, like health, I can't imagine there would be any. These are it's essentially just an accelerometer. At least the devices that I was seeing. It was actually this group at Tulane University. I went to interview there. I almost went to grad school there, and they were working. They had like a DARPA grant to work on a helmet that would do that. I think it was for the Air Force though, but. In any case, yeah, I mean, it's a fairly simple device. It's if you're, it's not like you have a microwave next to your head or anything, and so no, I mean, I can only imagine upside. I imagine the only limiting factor is whether or not the military wants to pay for it. What's your YouTube called? It is called Anthropoid. Not the name I would have chosen, and I thought I was going to do this kind of stuff, but yeah, it is youtube.com/anthropoid, and you can just probably search Ian Brain, or Anthropoid Brain or something like that, and it should come up. It's live right now. We would be using sign language if we never evolved speech. Yeah, probably. Well, I mean, we would probably be doing something that's very similar to chimpanzees or bonobos or baboons or other primates, right? They have the closest anatomically, the closest to a human brain. And they have language. Like, don't get me wrong. It's not like, it would be totally not possible, right? Something like communication will inevitably arise in, any group of primates. It's just the precision of human language that is, leaps and bounds greater than those of other primates. And of course, body language, like, written language or spoken language is just one very important part of communication. Like, even within speech, there are things that are oftentimes, I think, subtle or you don't like consciously consider, like prosodic language or prosody. It's like those are like the intonations. Like, my favorite example is, this is an example of prosody. I could say, hey, or I could say, hey, right? Same exact word, probably about the same duration of the word, but totally different meaning conveyed, right, by that intonation. And, interestingly, some languages kind of actually intentionally use that, like Chinese, Mandarin, well, I guess also Cantonese. Intonations are just as important as the pronunciation for words. In English, that's not so much the case, but it clearly does matter, right? So there's like that, we could just use vocalizations and have only prosodic, right, communication. We could still we could still communicate, right? And there's more. There's body language, of course, is critical. In fact, on the YouTube, so I always go live on YouTube first, and I talk about a specific topic. But really quick in the beginning, I have started this new job, and they're doing a lot of mitigation, but for like 1 or 2 days a week, I go into the office, and everybody's wearing masks, of course, and of course, like who wouldn't anticipate that it would be a little different starting a new job wearing a mask? But it's just how much it interferes with abilities to like make meaningful relationships, make a first impression, when all that people can see is just your eyebrows and your eyes, right? And like one example is when you're making a first impression, oftentimes people will like say a joke or whatever, just say something lighthearted, and you wouldn't like crack up and like guffaw and be like just boisterously laughing if the joke didn't really anticipate that kind of a reaction. You might like grin or like smile a little bit, whatever. When you can't see that, it's like it's so awkward. So that's something that's been kind of odd to confront. All right, thoughts on the byproduct of brain activity. Thoughts are the byproduct of brain activity, like tailpipe smoke. Yes, I agree. That's right. The consciousness and thoughts are what the brain does, or what the brain produces. Downloading books into our brains isn't yet possible. No, it's definitely not possible today. I mean, it is. Like, we do that all the time, right? But, by reading, by using written words, that is a way to download thoughts, to the brain. But, obviously, that's not what you're thinking of. I've been waiting for 15 minutes. My brain is fried. Oh, sorry about that, man. Hello, doctor. Do you think those world governments show psychopathic characteristics? Those world governments show psychopathic characteristics. Like the entire government? I mean, I would argue that certainly some dictatorships, totalitarian, authoritarian countries behave in ways that would be considered psychopathic, but even not really. I mean, from their perspective, they're acting in their own self-interest. I knew this would be about beer. Verbalization. The brain does not produce consciousness. Okay, I disagree. Verbal acuity and rhythmic verbalizzarono of verbalization of one's message. Yeah. I like to wear sunglasses with my mask so people glean nothing from my facial appearance. I remember in the early days, it wasn't even that early. It was like the third months of the U.S. confronting COVID. Like, the ability of SARS-CoV-2 to infect various like membranes on the face was pretty, worrying. And for a while, at the time, I was a policy advisor to a candidate for the state house here in Pennsylvania. Initially, before COVID, I was really just focused on opioid addiction, because opioid addiction is a very significant challenge in Philadelphia. Philadelphia is like one of the cities that's being hit the hardest by the overdose fatality epidemic, and so there's some interest in trying new things because the status quo is just failing to deal with this problem or to alleviate it. And so that I wrote essentially her proposal for what we can do. But then, of course, COVID-19 hit, and all of a sudden, the most pressing biomedical issue was no longer opioid addiction. And so I remember, looking into, should we be recommending people wear glasses and a mask? Anyways, yeah. So you weren't alone. Even I know you're kidding. How do we synchronize both hemispheres of the brain? So solar synthesis, that's an interesting way to put it. You don't really have much control over broad oscillatory patterns of the brain, right? So, and the meaning of those patterns is not as significant as I think a lot of people presume. So, just to give you an example, some patterns of brain activity are like alpha waves, or delta waves or theta waves, and these correspond to various kinds of dispositions. Like if you're sort of actively sympathetic to your environment, if you're taking in information and thinking about it and engaged, that'll be one pattern of brain activity. Another, if you're sitting there meditating and breathing deeply, and that is a different kind of pattern of broad activity in the brain. But it doesn't really tell you much else other than this person is engaged or this person is calm. It doesn't tell you what somebody's thinking about. And apart from sort of maybe long-term benefits of meditation and stuff like that, it's not like alpha waves are worse than theta waves, right? It's just they're used for different, they're associated with different states of consciousness, different mind states, and so beyond being able to influence those types of patterns, you can't really dictate what the brain is doing in any given moment at that level of control. and you probably wouldn't want perfectly synchronous hemispheric activity, right? Generally speaking, I mean, the brain is a bilateral structure almost entirely. There are some structures that are not bilateral, meaning like symmetrical, meaning like you have a hippocampus on this side and you have a hippocampus on this side. Amygdala, that sort of a setup. Some brain regions, like the ones I studied, are not symmetrical like that. But there are, and so as a result, there are very few things that there are comparatively fewer things that exclusively arise from one hemisphere and not the other. But there are some. So like language, for example, is sort of notoriously one of the lateralized processes where, a little bit more left hemispheric activity is associated with language than right hemispheric. But both hemispheres are involved. So like if your goal is like, I want to make my brain healthier, or I want to be calmer, I want to reduce stress, focus on that. Don't worry about like controlling, patterns of brain activity. Focus on the things that have been shown to reduce stress, like, meditation, mindfulness meditation. Yeah. Oh, somebody's calling it. I thought so. Solar. It's a cool handle. I think we're connected. What's your name and where are you calling from? Hey there, Solar Synthesis.
Hello?
Hey, what's your...
My name's Carl. I'm from Maryland.
Cool. Okay, what's on your mind?
Yeah. So there's a bunch of questions. I'll just start with one. So I don't know if anyone's asked about gamma rays or gamma waves yet. And how do I phrase this properly? So are beta brain waves useful for us in our day-to-day lives? Like, some people say beta waves are linked to anxiety, or like, I'm not sure, but they just say that beta, we want to increase more of our alpha, theta, delta. But then does that mean that beta waves are necessarily bad?
See, yeah, that's the thing. Like, no, there's nothing intrinsically superior to having one pattern of brain activity than the other.
Okay.
And also, like, there's very little you can do to really dictate your transition between those patterns. I mean, you can, like, by meditating, you can sort of slow down so what we're talking about here are basically sort of a spectrum of how slowly waves of activity propagate throughout the brain, and it's very broad scale, right? So here, let me give you an example of why, like, focusing on these waves isn't probably the thing that's going to get you to what your ultimate goal is, whether it's, again, calming down, becoming smarter, whatever. Imagine, again, our bar example, imagine your goal is to find out what everybody's doing, what everybody's talking about and thinking within a bar. Here in Philadelphia, it's packed, right? Well, not these days, but back in the day. You could do a couple different things. You could, again, go person by person, talk to them, understand what they're talking about, all that kind of stuff. That would be like recording from neurons. You could just listen to the conversations that different groups of people are having. That would be like recording from collections of neurons. Or you could, like, take the roof off and look down at the bar from, like, a helicopter to try and get an understanding of what's going on in there. And you can learn some stuff about what's going on in a bar by looking down on it from a helicopter, like, hey, nobody's fighting right now. There's more men than women in here. You can still learn stuff about it, but it's so high level that it's really not a meaningful representation of, or it doesn't meaningfully get you to your goal. So that's all this to say, like, focusing on alpha waves, delta, theta, it is a very, very crude representation of what's going on in the brain. So, and all that to say, ultimately, no, that, like, there's nothing intrinsically negative about any one of those patterns. They all serve different, or are associated with different functions. Like, if you could never experience alpha waves, you would be very difficult to interact with because you wouldn't be, like, sympathetic and engaged in your environment. Similarly, if you could never experience theta waves or, whatever, some of the slower oscillatory waves, then you'd probably be very stressed out. But you need to be capable of both of those things to successfully navigate life, right? So, and generally speaking, just one last thing I'll tack on is I know a lot of companies sell devices and, brain waves, those types of things.
Brainwave entrainment or something.
Yeah, and like there is some validity to the concept of using, just so everybody's on the same page, the whole brainwave market, let's say, is essentially premised on using auditory, like, sounds that sound sort of like really bad dubstep. So it's like low frequency oscillations, like vroom, 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 like that, like patterns of those kinds of sounds. And because that necessarily translates to patterns of brain activity, right? Your brain is interpreting those oscillations. But then theoretically what you could do is then influence other parts of your brain that don't have a direct auditory role for some kind of goal. And the goals can get rather exotic, that these companies, like it'll induce the feeling of being high on cannabis or LSD, I've seen like that kind of stuff. But there's a grain of truth to it. But generally speaking, whenever I see a company making those claims, they're very pseudoscientific, unfortunately. So, yeah, okay. I'll stop.
Can I ask another question?
Yeah, of course.
Okay, so I think I have two more main questions. So one, devices like the AirPods and stuff like that, right? I've seen a few videos where they show the electromagnetic radiation being emitted from these devices, and one of my friends recommended that I don't, or maybe limit my usage of these devices such as AirPods, just because they're communicating, right? So let's say I have both AirPods in, they're both communicating with each other, and my brain is right in between where like these two devices are communicating. So in your personal opinion, it's like of everyone in this Bluetooth technology era, like what's your view on wearing devices like these where it could or maybe not causing harm to the body?
Yeah, well, I mean, probably the easiest way for me to tell you my personal opinion is that I own probably like 6 pairs of Bluetooth. In fact, I have some right here. These are not AirPods, but obviously they all use Bluetooth. Yeah, they're essential for me in the lab. Like if I didn't have those, I would probably lose my mind, because I would do like 14, 15 hour viral infusion surgeries straight. And so, I can't have a cord all, cramping my style, right? And so yeah, I use them a lot. So it is a totally reasonable and rational concern to have, because your friend is absolutely right. It is using a form of electromagnetic radiation to, sustain Bluetooth connectivity. Now, here's why I would never say it's impossible, right? It could very well be possible, or it could be possible in very specific circumstances where people, have some kind of susceptibility to some kind of malady. But for any kind of form of electromagnetic radiation to meaningfully interact with a biological system, either the wave itself, the physics of the wave, are such that it can physically interact with a molecule in the cell or in the body, or an electron. It can pop an electron off of an atom, causing potentially cancer. It can disrupt genetic material, again possibly causing cancer. And there are some parts of the electromagnetic spectrum that can do that. Wait, okay, so either the radiation has to have those features, those physical properties, or there has to be some biological system that evolved to be sensitive to some part of the EM spectrum. To give you an idea, visible light, the only way that you can see this conversation that we're having right now is because of electromagnetic radiation in the form of visible light. And the only reason you even know that it exists is because we have photoreceptors in our eye, right, that are sensitive to different wavelengths along that little sliver of the electromagnetic spectrum. If we didn't have those, you would have no idea that it even exists. And it wouldn't cause any kind of cancer. You don't worry about being around, the light from your computers, right? Why would you?
Yeah.
Similarly, Wi-Fi, Bluetooth, 4G, 5G, all of these, radio waves, all of these
are forms of electromagnetic radiation. And I haven't heard anybody being super concerned that we're essentially bathed in radio waves, right? There are some people who are mistakenly overly concerned about 5G, but that's a different topic, maybe for another time. So all of this to say, I've never seen any evidence, and it has been evaluated, never seen any evidence that Bluetooth, let alone cellular and all those other EM spectra, have any meaningful interaction with the biological systems. So that's my response, is that, I don't have any reason to kind of assume that there would be an interaction, and I've certainly never seen any evidence that they do.
And if there were, wouldn't these companies like Apple they've already done their research, obviously, because they wouldn't want the risk of somehow, I don't know, I'm assuming that they thought of this before they released the product into the market. So maybe
I mean, I hesitate to give any like big giant profitable company that much credit, but and frankly, I wouldn't trust their research, but there are scientists like people in my position who could make a hell of a career, by finding out that, hey, Bluetooth or radio waves, whatever, have some kind of carcinogenic effect, which is usually the concern that people have over these things, is that they might cause cancer. For sure, cellular radiation has been evaluated many times at this point, my assumption, my expectation would be that very comparable in terms of how they would interact with the body. So you said you had maybe one more topic?
I have one more question.
Right on.
Just because I don't want to, let me know when you want me to stop, because I could go on all day.
Yeah, let's go for this next one.
Okay, so a lot of people, or just in general, say that we're not using, whatever, the full capacity of our brain potential. And then there's also all these products that claim, like all these binaural beats and whatnot that claim to activate the full potential of the brain, blah, blah, blah. So is it a myth that we're using a very small fraction of our brain potential? And if so, how do we fully activate it to our best ability? Like, I'm pretty sure, among the geniuses of our time, pretty sure they've used their brains to a much higher extent than we do as a population right now. So how do we reach that state of, I guess, I don't want to say consciousness, but let's just say brain activity. I don't know.
I think, consciousness is a fine word to use. So let's start with what we know for sure. That the notion that humans only use 10% of our brain, or maybe there's other numbers that are thrown around, 10% is usually the one that I see the most frequently. That is definitely a myth. There is no sort of law of physics that's limiting how much brain activity any human is exhibiting at any one time. The only limitation is that if you go beyond a certain point, you're going to start having seizures, right? That's essentially what a seizure is. It's just runaway electrical activity. But then the second part of that is performance. Let's say intelligence or athletic performance. All of these things arise out of expertise, right? As opposed to just cranking up the volume in the brain. And in fact, right, if you were to compare the brain activity that I would exhibit, trying to, let's say, play the guitar, compared to the guitarist from Polyphia, or a really good guitarist, they almost certainly have far less brain activity, because it's less about just deploying all of the weapons that the brain has. It's more about honing in on only the most critical, yes, exactly, amount of brain activity. And here's why. Let's go back to our bar example. We've learned a lot from bars today. So imagine you and I are having this conversation right now, and we can hear each other pretty well, and we're sitting in a bar, and we're the only two people in the bar. And so we're having this conversation, very effective communication, right? Now imagine if, the Eagles just played and won, and the bar gets flooded full of people, and they're all screaming and rowdy and bumping into each other, bumping into us, getting in our way. We can't really see each other. That would be the equivalent of like, instead of having just the amount of brain activity you need to execute the task or, perform certain, cognitive processes, thoughts and stuff. Instead of doing that, you've just turned on a bunch of other stuff that doesn't matter to the task, and so you're very, very distracted, right? So that is the sort of the misunderstanding. That's the myth and the the myth and the misunderstanding of what's of that whole relationship. But the other part of that topic is basically, how are we successfully exploiting all the capabilities available to us from the brain? And I think there's some truth to no, we're not even close, maybe. And my evidence for that submission is that language hasn't even existed for very long. Let alone the internet hasn't even existed for very long. I mean, it is younger than I am, right? And I'm not that old, and so I think we are at this point where human evolution, the name of the game is cognitive evolution at this point. It's how quickly cognition, human consciousness, communication, society is evolving. We're not so much relying upon biological evolution by natural selection. We're relying on cognitive evolution to accelerate us, accelerate our realization of the human potential, right? So I think there's some truth to that. Now, if I could tell you the best way, well, here's like a way to amplify your potential that is almost certainly true. Just keep trying to challenge your brain. Just keep learning new things, expose yourself to new ideas, learn a new skill, learn how to play the guitar. If you can't play the guitar, learn how to play, the piano if you can't play that. Learn a martial art, learn a new dance. Force your brain to solve a ton of different kinds of challenges, unpredictable challenges, because that is basically, that's the bicep curl of the brain, right? And so that is almost certainly true, right? Another one is try and get enough sleep. The brain really does need sleep. It's not like a nice to have thing. It's a need to have type of thing if you want your brain to function optimally. So, and it's really those two things that are pretty surefire. They're not particularly sexy or romantic, right? It's not like, oh, you just need to listen to, Jimi Hendrix's Voodoo Child and, do 15 jumping jacks and boom, your brain is ignited. But it's more like interacting with, the brain on its own terms through its own systems. And that can just set you up to be able to confront new challenges, new thoughts, new ideas, blah, 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 more competently. But yeah, beyond that, I wish I had, if I had a better answer than that, I'd probably be a billionaire by now. All right, man.
Thanks for answering.
My pleasure. Thanks so much for calling in. Great topics. Oh, okay. All right. Guitar is fine, but if you want to be cool, learn bass. I think we all know what instrument Scott plays. Scott, I don't know if this style is really your style, but I suggest you check it out. Check it out. A song called "Goat" by a band called Polyphia. These are pretty young guys, and I don't know. They're extremely impressive musicians, even if you don't like the style. It's kind of a weird style. It's not like what you would normally think. Hey, what's up, Asha? I'm sorry I missed you. How do you think COVID affects the sense of smell? I love that topic. Evolver Man. The short answer is we do not know. The short answer is that we're not 100% sure that it does. But I remember when it first came out, there was like a report. I think it came from like a group in France, just like made this observation that like they're consistently seeing these patients who are saying that they've lost their anosmia. They've lost the ability to smell and or taste. You know what? I actually talked about it on YouTube a while back. If you want to check out like the more contemporary evaluation. But so when it first came out, right, our understanding at the time of COVID, and this has become much more complicated since then, was that it's a respiratory virus, that it infects the cells that line your respiratory system, and causes a ton of inflammation. And I don't know if you've ever had the flu or another coronavirus, another respiratory virus, but if you have enough inflammation in your nose, like, you physically can't smell things because the air molecules can't get in there, or that the mucosa, the nasal mucosa, is so disrupted that even though you can breathe through it, the odorant molecules aren't doing what they would normally do when you breathe in and smell and taste. So, like, I was sort of like, well, duh. Like, even if you have allergies, like, yeah, you're going to lose some of the ability of olfaction, right? That was my first take, was like, these are physicians just playing purely with statistics, not really thinking deeply about the biology. But since then, I mean, it has become consistent enough that it does strike me as being like a real effect. And the reason it's so interesting to me is that, first of all, it could just be a physical, inflammatory reaction along the nasal mucosa, along the respiratory system, where the inflammation itself is so significant that it disrupts some of the cells in the area, some of the parts of biology that are necessary, of your biology that are necessary for you to smell things and taste things. So it's just like a local effect of, not of the virus itself, not of the virus attacking cells, but rather of your immune system reacting to it, mostly the innate immune system, just flooding the zone with inflammatory factors, and like sort of like carpet bombing a city rather than sniper rifling somebody right from Broadway. So that's one potential effect, and frankly, I think that's probably the most likely. Another, however, is that SARS-CoV-2, the virus that causes COVID-19, may, in some cases, be able to escape the respiratory system and infect other organs, other systems. And I think we're fairly confident that it can do this now, and that might explain why it is that some people have, multiple organ failure, clotting abnormalities, and dementia, or symptoms of dementia, a lot of like neurological conditions. In fact, there were enough neurological conditions associated with COVID-19 that a hospital in Italy opened up a ward devoted exclusively to neurological COVID-19 patients. Okay, so there is also evidence that other coronaviruses, like the one that caused SARS, was detectable in the nervous systems of some patients in China. Doesn't necessarily mean that it means that the virus does anything meaningful once it's in the nervous system, but it means that it's possible if it can escape the respiratory system. Yeah, and at this point, from what I'm reading, I think most immunologists, virologists are pretty confident that there's something different about SARS-CoV-2. It mutated, of course, right? That's why it's a separate virus from the one that caused SARS. And I am pretty confident, and you can hold me to this, that we're going to find out that some of the mutations that occurred to create SARS-CoV-2 are in very specific components of the viral particle that make it more versatile than SARS-CoV-1. And so my second prediction is that I bet we're going to find out that there are some genetic predispositions that some people might have to reacting to SARS-CoV-2 in different ways than the norm, right? And, this kind of biology explains a lot of different maladies and, predispositions to addiction, predispositions to obesity, right? There are genetic predispositions. And I'm not 100% sure, but I bet that we're going to find out that some people who have, this form, this SNP, this single nucleotide polymorphism in, the ACE2 receptor, angiotensin receptor 2, or the TMPRSS, they have SNPs in those things that are subtle, meaningless otherwise, until this virus just happens to be able to interact with the receptor in such a way that it becomes much more dangerous, which could potentially explain why the vast majority of COVID-19 patients are fine. Like some of them, they're totally asymptomatic. You wouldn't even know that they had it. So yeah. But obviously some people react super fatally, right? They react fatally and terribly. So all of this to say, back to the loss of smell, either it is this local effect of inflammation on the nasal mucosa and the olfactory biology, or it has in some patients the capability of gaining access to their neurobiology. It's one of those two things, and it could be both, by the way. So yeah. Est-ce que tu parles français? You like James Woods? It seemed like two totally different topics. All right, Android, how do you explain someone's learning ability with ADHD versus someone without? Let's see. That is the same person. All right, yeah, it looks like you're calling in. So why don't we just talk about it? Okay. That I have to admit that was pretty creepy, but I think we are connected. What's your name and where are you calling from?
Name's Angelo, actually, and I'm calling from Maryland. So I just wanted to ask you some questions about ADHD and how someone absorbs that information versus another person who does not.
Gotcha. So ADHD, for everybody that's unfamiliar, is I guess it's considered a learning disability, but basically it is a difference in the way that some people sustain motivation, essentially. Sustain focus and motivation on any given task. It can manifest in a couple different ways, actually. Like some folks have experienced what's called hyperfocus, where they'll sit down and play a video game for like 12 hours, not eat, not shower. They're super devoted to this one task. But the more common, more sort of widely familiar is the opposite, where folks just have real difficulty sitting down for longer than 10, 15, 20 minutes focusing on a single task. And so what's the difference in the brain between folks like that and people who don't have ADHD? Well, we don't know 100% for sure, but we're pretty sure that there's some difference in a part of the brain called the mesocorticolimbic dopaminergic circuit. So don't worry about that first word, but I bet you recognize the second word, dopaminergic, dopamine. And so this is a circuit. It's a pretty ancient evolutionarily circuit, at least part of it, where neurons in a part of the brain called the ventral tegmental area that synthesize a lot of the dopamine that circulates in the brain, they send these projections to the front of the brain, to the limbic system and the prefrontal cortex. And so it is that dopaminergic signal from those dopamine neurons in the VTA, the ventral tegmental area, landing at the prefrontal cortex that is a very significant governing factor over how long a person has the motivation to stay devoted to a given task. And here's why. That dopamine also, those same neurons, or some of the same neurons, send dopamine to a different part of the brain at the same time called the the nucleus accumbens or the ventral striatum. It's part of the limbic system. It's part of your mood. It regulates mood. And so so essentially what this circuit is doing is evaluating how significant the reward or the benefit, the payoff of any given behavior or task or work will be at its conclusion, and therefore how long you should spend focused on this task, right? So just to let's make it a little bit more tangible. So, let's say you have a biology test tomorrow, right? And you should be studying, right? And you don't know the stuff enough, but you just cannot motivate yourself to sit down for more than 5 minutes to learn about the damn Krebs cycle, which is like, it's just abusive that we still have to learn the Krebs cycle. But part of the reason for that is that you do not anticipate the downsides of not studying to be significant enough, so the avoidance of aversion, or you don't anticipate that the payoff of studying, getting a good grade, will be significant enough to be preferable to playing video games, talking to me right now, doing other things that are more rewarding. They're more rewarding. So when it comes to ADHD, it's a difference in that circuit. And that's why the primary medications that are used to treat ADHD, and they're quite successful at doing so, are dopaminergic drugs like Adderall or amphetamine, Ritalin or methylphenidate, right? Those two drugs target that exact circuit, which is probably why we haven't found a better treatment for ADHD than those drugs, more effective treatment. So that's the primary difference. And from my perspective, the goal with ADHD is not to cure it or to change a person's brain so that they no longer experience that difference. Rather, it's to give them tools to enable them to function more easily, have a higher quality of life, but then still be able to exploit the unique aspects of having ADHD, the increased creativity, the increased dynamism, the ability to just, bounce between different things and be fully engaged and then move to another topic. Oftentimes people with ADHD are extremely creative. That's my whole take on ADHD.
Got it. Thank you so much. I don't want to take up your time because I know you have other guests here. But thank you so much. I really appreciate your time.
Thanks for calling in, man. Great topic. Let's see. Wow. So the girls are napping right now. I expected them to be up a while ago. But hey, when the girls are sleeping, we will play. All right, somebody else is calling in. I love how many callers today. It's awesome. All right, looks like we're connected. What's your name and where are you calling from?
Hey, I'm Holly. I'm calling from Austin, Texas.
Awesome, Holly in Texas. What's on your mind?
Hey, read my bio. That will make it so much shorter. I have head trauma.
Okay.
And I want to be Neuralink's first patient.
Gotcha.
I don't know what your opinion on that was.
Well, I mean, that is super courageous. Well, okay, so here's the thing. So I talked about Neuralink a bit on YouTube, their latest presentation. And here's the short story is that the technology that they're presenting is an innovation on existing technology. Like in the lab in which I worked, we did something very, very similar to what they presented, not in pigs, but and so it's not like they are presenting a technology that the world has never seen before. And so I don't mean to imply that it's extremely risky because
How about deep brain stimulation?
there you go. Yeah, deep brain stimulation. But then also just from a research perspective, we literally did that kind of thing in the lab, not for the treatment of any maladies, but all of this to say, we do have some sense of what the risks would be. However, they are doing some different stuff, right? They are innovating. And for example, the number of electrodes that they're planning on including in their implant is far, yeah, well, sort of. It's far higher than deep brain stimulation or current treatment modalities. So there's that. The other is that the amount of data that they are planning on collecting and also stimulating is significantly greater than any device that we've had before. So all this to say, the first folks who are courageously going to test out this technology for the rest of us, it is courageous and it is risky. Any brain surgery is always very risky. But
Yeah, I've had trauma from the surgery.
Oh, really? I'm sorry to hear that.
Yeah, I've had cavernomas in my cerebellum.
Wow. Okay.
Yeah.
Well, yeah. I mean, so I don't have to tell you.
Another question.
Sure.
Do you know anything about vascular neurotransmitters?
Vascular neurotransmitters, meaning just neurotransmitters that circulate within the circulatory system in the blood?
I don't know anything about how it works.
Well, I mean,
My mom told me to look it up.
okay. So I guess I'm not sure in what context somebody's referencing vascular neurotransmitters. Neurotransmitters, that it's sort of a soft category of molecules. There's no intrinsic difference between neurotransmitters and hormones, for example. They're both molecules that are released from one cell and influence another cell. In the case of hormones, usually that other cell is far away in the body and it takes a long time, whereas neurotransmitters are usually a little bit more moment to moment. But just to give you an idea, in the brain, we have a neurotransmitter called epinephrine or norepinephrine. And that same exact molecule we call adrenaline or noradrenaline as hormones in the body. So, and they circulate through the blood. So I would imagine that's really what they're referencing, is that some neurotransmitters are delivered, or some signaling molecules are delivered to their targets by through the blood rather than from neuron to neuron directly. But apart from that, it's not a category that I've heard formally used. It's just, a different substrate for a signaling molecule to be released. So, once again, in case you couldn't hear it, epinephrine, norepinephrine are neurotransmitters in the brain, the central nervous system. And the same exact molecules are adrenaline and noradrenaline as hormones in the body, and they use blood to circulate. So they would be vascular neurotransmitters, arguably. But beyond that, I'm not entirely sure. My friends that I saw Saturday, husband was sick 3 days, got better, wife never sick, has antibodies. That's awesome. Yeah, that's what I'm hoping, man. But, yeah. Oh, Ken Norton, your exact question. Awesome. I imagine you were interested in the ADHD. What causes norepinephrine to be released? All right, this is good stuff. So norepinephrine is, it's actually, believe it or not, it's synthesized from another neurotransmitter, very famous neurotransmitter. More famous neurotransmitter has a better PR agent. Dopamine. So norepinephrine is synthesized from dopamine, and epinephrine is synthesized from norepinephrine. Kind of cool, right? It's actually very frustrating because oftentimes when you're trying to identify dopaminergic neurons, exclusively dopaminergic, sometimes you end up also including noradrenergic, norepinephrine neurotransmitters as well. Frustrating. But anyways, a part of the brain called the locus ceruleus, sort of a brain stem structure. It's tiny, very tiny. I targeted it with virus like 2 times, and it didn't end up being important for my project, but it's very small. Bilateral structure, locus ceruleus. Which basically means blue place. And that the reason for that is that if you were to slice my brain open and look at my locus ceruleus, it has a sort of bluish hue to it. And I think that's due to the dopamine beta hydroxylase, it appears a little bluish. Anyways, it's kind of cool. So that part of the brain is, the main source of norepinephrine that we focus on in neuroscience. Generally speaking, norepinephrine release is induced by some kind of sympathetic reaction, meaning something's happened in your environment, it's novel, and then potentially aversive. Maybe you're afraid somebody's going to attack you or make fun of you, or any kind of just negative aversive experience will elevate norepinephrine. And then what stimulates that? It's some neuron, amygdala, some neuron in the amygdala for sure, will send, this isn't the only way, but will send projections and therefore signals to the locus ceruleus. The amygdala has detected a potential, has been triggered by a novel event in the environment that you are evaluating as being potentially aversive. So the level of activity in the amygdala has escalated, and therefore neurons in the locus ceruleus will be released. Norepinephrine in the locus ceruleus would be released. How long has it been? Oh, wow, it's been a while. All right, I should call it a day. I'm so glad I got to do this again. It feels so good. I love talking to you guys. It's so fun. Reminds me of why neuroscience is, I think, the coolest scientific discipline. Certainly the most interesting. Definitely the hardest and most important. I'm kidding. I kid, obviously. I have a YouTube channel. It's called youtube.com/anthropoid. You can search for Ian Brain or Anthropoid Brain. You can probably find it that way, because I know everybody knows how to spell the word anthropoid, right? And today I talked about the update to Neuralink, the presentation that Elon Musk did about a week ago. My thoughts on it, what we really learned from it. We scrutinized it a bit. What is actually new here and what is just theatricality. I have a podcast called Wired to be Weird. It's on iTunes and Stitcher and where all fine podcasts are podcast. And I haven't updated it for a while, but it has a lot of topics that I think a lot of people find interesting, like why do we have dreams? What is dementia? Is addiction a disease or a disorder? What is schizophrenia? All of these types of things. So check it out, Wired to be Weird. Let me know what you think. And if you want to ever ask a question, feel free to reach out on Twitter. DMs are open, always. _anthropoid. You can get to it through Periscope. Otherwise, I am going to try and do this again next week, hopefully on Sunday rather than Monday. But hope you have an awesome Labor Day if you're celebrating in the United States. Otherwise, have a great beginning and rest of your week. Stay safe, wear your mask. See you next time. All right, YouTube, thanks for watching, everybody. As always, I am super open to any advice you might have. My time is obviously limited, but if you think I should change something about what I'm doing, please let me know. I'm super interested. Otherwise, if you haven't subscribed, I would appreciate it if you would subscribe. All right. Thanks for watching, everybody. See you next time.